Okay, hi everybody, welcome back. So, like the last section, we explored all about the graphs of the sine function and the cosine function and their variations. Now we're going to look at the other trig functions, namely the tangent function, the cotangent function, the secant function, and the cosecant function. And they're going to be a little bit, well, they're actually going to be a lot different. And the reason for that is that just like you can take the sine and cosine of any number or any angle, but you can't take the tangent or cotangent of any angle because you have to worry about dividing by zero. For example, with the tangent function, the tangent is sine x divided by cosine x. So this is undefined when the cosine x is 0, and that will happen exactly at, well, infinitely many numbers, but namely pi over 2, plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2. Basically any odd number times plus or minus pi over 2. That will be a troublesome point. And what happens is that at those points, there is no point on the graph. Instead we have a vertical asymptote. And if you remember how vertical asymptotes, when we were doing with rational functions in Math 128, you look and see where the denominator is 0. Okay, so that's how you get these vertical asymptotes here. And so, in particular, well, we know that by the way, this also tells us the domain of the tangent function will be all numbers not equal to these troublesome points, not equal to plus or minus k over pi over 2 when k is odd. Okay. So we plot a few points of the tangent x just from minus pi over 2 to pi over 2. And we really just need to consider that because we proved last time in another video that the tangent is periodic, but its period is pi. So it repeats every pi units or pi radians. So what happens here, we can plot these points and we can see that from negative pi over 2 to 0, these values are negative. We start with a big negative number, and then the negative numbers get closer and closer to 0, and then from 0 to pi over 2, everything's positive, and the numbers start increasing again. So we have, so the graph from negative pi of tangent x from negative pi over 2 to pi over 2 looks like this. Okay, we have a vertical asymptote at negative pi over 2, and on the right side of this asymptote, the graph shoots down. And at pi over 2, to the left of that, the graph shoots up. Now, this actually repeats every pi unit. So we'll have another vertical asymptote here. This time at 3 pi over 2, and graph will look basically the same as it did in the previous zone. Okay, incidentally, this y-intercept here is going to be a pi. Okay, and then we can go back here and then go back the same amount, and here we are at negative 3 pi over 2, and here's negative pi. And we'll get another similar graph like that. Okay, and it just repeats every time. So we have infinitely many intercepts. We have infinitely many vertical asymptotes. Okay, so to summarize, we have a vertical asymptote at these numbers plus or minus pi over 2 times some odd number k. The x-intercepts are at the multiples of pi. And the y-intercept, of course, is at the origin. The period is pi. The range is negative infinity to infinity because you can pick any y value, and there will be a point with that y value somewhere on this curve, right? So another way of looking at this is you can take any horizontal line that will intersect this graph at some point. Actually, it will intersect it at many points. Okay, now to generalize this, we want to be able to, what does this have to do with the graphs whose equations are of the form a times the tangent of bx? Well, the period in this case, because when you replace x with bx, remember that's a horizontal compression or stretching, and the period now, all the x coordinates are divided by b, whatever b is positive. So the period is going to be pi divided by the absolute value of b. And the vertical asymptotes are also going to be shifted horizontally. So the way we do that here is, well, the vertical asymptotes will be where this is undefined. This will be undefined when the cosine of bx is equal to 0. That happens when bx is going to be in this form. We have, plus or minus k pi over 2. Okay, so we can divide both sides by b, and so we get the vertical asymptotes at plus or minus k pi over 2b, where k is odd. Okay, and that's how we get this. The absolute, it turns out that because of this plus or minus, we don't need the absolute value here. Okay, but that's why this works. So that's how that will work. Okay, so maybe we'll do a now let's talk about the cotangent. Cotangent, of course, is the reciprocal of the tangent. It's also equal to the cosine divided by the sine. So this will be undefined where the sine of x is 0. And we know that the sine of x is 0 when x is some multiple of pi. Okay, so x is k equal to k pi, where k is any integer or any whole number. So now if we plot some points here from 0 to pi, and by the way, that the pi is the period, is also the period of the cotangent function. We can see that from 0 to pi over 2, the values start off being very large and then going down, large and positive, and going down to 0. And then from pi over 2 to pi, they're negative, and they get very large and negative. So that explains this graph right here. Okay, of course, at pi over 2, the cotangent will be 0 because the cosine is 0 and the sine is 1. So, all right, and just like we did before, this repeats, so we can have another asymptote here at negative pi, and have something like that, and this will be at minus pi over 2. That will be that intercept. And then we'll have another one over here, another asymptote at 3 pi over 2, or rather at 2 pi, and then we'll have a graph like this. Okay. This will be at 3 pi over 2. So we have the vertical asymptotes at all the multiples of pi, and then the intercepts will be at all the numbers in the form of k pi over 2, where k is odd. And we can see there are no y-intercepts, and the period is pi. The domain will be all x not equal to a multiple of pi, and the range, of course, is negative infinity to infinity, because again, you can take any horizontal line and it will cross this graph at least once. Okay. And so what about the graphing functions, graphing equations like this, where we have a times the cotangent of bx. Once again, the period will be pi over b. The vertical asymptotes were basically stretching, we're compressing them or stretching them horizontally again. So so before they were k times pi, and then we just divide by b, or the absolute value of b, and those will be the vertical asymptotes. Okay. All right. So let's look and see. Let's put this into action and plot some things without a graphing calculator. So guidelines for graphing. Basically, when you're graphing either a tangent or a cotangent function, and oops, why did I have a plus c here? This should be plus c over here. Okay. this is, first you want to find the period and find the vertical asymptotes. And once you find the vertical asymptotes, then it's just a matter of where do you plotting a few points and connecting the dots, and you're done. So find the period, find the vertical asymptotes. Actually, if you find the vertical asymptotes, then the distance between any two vertical asymptotes is going to be equal to the period. And then you sketch one cycle of the graph between two consecutive vertical asymptotes, and then fill in the rest. So, for example, with the tangent of 3x. So, this is a case where a is 1 and b is 3. We're not going to worry about the a so much because there's no amplitude obviously in this case. So the period now will be pi over 3. Okay. Now, now and the vertical asymptotes. Well, you just find out. Okay, this will be where the cosine of 3x is equal to 0. Okay, and that's going to be okay. So the cosine of 0 is when so 3x will be at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. Okay, and then if you divide by 3, x is going to be plus or minus pi over 6, plus or minus 3 pi over 6, plus or minus 5 pi over 6, and so on. So there are your vertical asymptotes. And in particular, this is going to be where at pi over 6, negative pi over 6 will give you one pure fundamental cycle. So here's pi over 6, or negative pi over 6, and here's pi over 6. Okay. And so now you can just go ahead and plot some points. And you really don't have to plot too many. You can basically divide this up into 3 points here at the origin, and then halfway between so this would be pi over 12 here and negative pi over 12. And you say, well, I don't know what pi over 12 is. That's okay, because you're going to be multiplying it by 3 anyway. So like if you quickly make a table here, here's negative pi over 12. Negative pi over 3 times this number would be negative 3 pi over 12, which is negative pi over 4, which is negative 45 degrees. So this tangent is going to be negative 1. And when x is 0, this is the tangent of 0, so that's just 0. And when at pi over 12, you can see that this will be tangent of 3 pi over 12, that's tangent of pi over 4, that's 1. Okay. All right, so you get these these 3 points here. Okay. So the graph is going to be looking like this. All right, so it looks like that, and then of course the graph repeats, like so. Okay. Okay, I did a terrible job on this last part, but okay. Let's look at the cotangent. The cotangent, when is that will be we'll get a vertical well, the period in this case will be pi divided by 4. Okay, and you get vertical asymptotes when the sine of 4x is equal to 0. So that means that 4x is going to be, plus or minus, it would be 0, plus or minus pi, plus or minus 2 pi, and so on. So if you divide by x, or if you divide by 4, what you get is you'll get 0 plus or minus pi over 4 plus or minus 2 pi over 4, and so on. Okay, well, we can say that we have, in particular, we'll have one at 0 and a pi over 4. So that's the only thing we're going to be concerned about right now. Okay, so we have an asymptote here and an asymptote here. And of course, the middle point will be pi over 8. And once again, we don't need to know what pi over 8 is because we're just going to plug that in here. So if you have, here's x and here's y. Do pi. Okay, we have a couple more. We'll have, this will be, half of this is pi over 16. And this will be 3 pi over 16. So 4 pi over 16, of course, will be pi over 4. And when you plug that in here, you get the cotangent of pi over 4, that is 1. The cotangent of 4 times pi over 8, that's the cotangent of pi over 2, that's 0. And then this will be, when you plug that in here, that will be tangent of 3 pi over 4, that is going to be negative 1. Okay? And if you'll excuse me when I answer the phone. Okay, thank you. That was a telemarketer, although the telemarketer sounded like someone in my family. Okay. Anyway, there was, so we have these points. Once again, it's going to be 1, 0, negative 1. So let's say if 1 is up here, you have them here, here, and here. And it comes out down, it's like that. Okay. Okay, and then of course the graph repeats just like that, and so on. Okay. All right. Let's look at another one, another example. So we have negative 2 tangent of x, y equals negative 2 tangent of x. The b in this case is 1, the a is negative 2. Okay, so the period is just pi. And I think we can say that we know where the vertical asymptotes will be. It's where the cosine of x is 0, which is going to be, and x is going to be plus or minus pi over 2, plus or minus 3 pi over 2, and so on. Okay, so once we can just take negative pi over 2 and pi over 2 again. Okay, and then here's our 3 intermediate points. We'll have one at halfway between, this is pi over 4, so this is negative pi over 4, 0 and pi over 4. And so the tangent of negative pi over 4, okay, negative pi over 4, the tangent is negative 1, but you multiply it by negative 2, so that'll be positive 2. For 0, it's going to be 0, and for pi over 4, this will be negative 2 times 1, so that's negative 2. So here's, here is 2, 0, and negative 2. So it will be up here. Go like that. Okay, this should be it. Okay, this is not well drawn, but you got the picture, I guess. All right, so it's just this negative 2 sort of, it flips the graph of the tangent of x and then stretches it in the vertical direction. Okay. About the tangent of 5x plus 2, we have, here. So in here we have, okay, we'll worry about this 2 in a moment. The b is going to be 5. So the period is pi over 5. Okay. And this will be undefined when the vertical asymptote will be when the cosine of 5x is 0. So 5x must be equal to plus or minus pi over 2, plus or minus 3 pi over 2, and so on. So x will be divided by 5, you get plus or minus pi over 10, plus or minus 3 pi over 10, and so on. Alright, so those are going to be, so we can just have negative pi over 10 and positive pi over 10. Okay, and the only difference is here. You can let me just say the intermediate terms. This will be pi over 20. So you can, here's x, y, negative pi over 20, 0, and pi over 20. All right. So the thing though is, if you plug things into here again, you actually get the points. Well, I have those 1, 2, and 3, and you get that's because of this plus 2 here. Okay, for example, the tangent of 0 is 0, but 0 plus 2 is 2. So, okay, so you get, so here's 2, and here's 1, and 3, and so the graph is kind of like up here. So it basically was, we had a graph, but we shifted it up 2 units. Okay, and then it repeats. And then I'll let you do, I'll pause the video. Maybe I won't. Let's look at this negative 3 cotangent of x plus 1. And see the period will be pi. Again, pi divided by 1 is, this is a 1x here, so period is pi divided by 1, which is just pi. And this is undefined when the sine of x equals 0. So that means x is going to be 0 plus or minus pi, and so on. Okay, so we can take our vertical asymptotes to be 0 and pi. And halfway between this is pi over 2. And if you make, so this would be pi over 4, and this would be 3 pi over 4. And so when you plug these in here, remember there's a minus 3. So we will plug in the pi over 4. That's cotangent of that's 1, but you have negative 3 plus 1 is negative 2. And then you can check that the other values are 1 and 4. And so you have negative 2, 1, and 4. Okay. So you have like this. Always make sure you don't touch the vertical asymptote. Okay. So these, obviously, when you draw them, just like when I draw them, they're not going to be works of art. The important thing is you'll be able to identify the vertical asymptotes, and we're not even going to be concerned about the x-intercepts. Notice I didn't calculate the x-intercepts because they can be very hard to do without a graphing calculator. Okay. So really, you just need to know where the vertical asymptotes are. Okay. And that's also, get some practice, do the homework. We'll do the other 2 trig functions in the next video. So take care. See you then.